Hi there, so today we're looking at lesson 14.3 compound measures. This is the first part of compound measures and we're going to have a look at comparing measures. So our objectives today then are to understand measures that are in direct proportion to each other. So remember, direct proportion means as one goes up, the other goes up at the same rate, or as one goes down, the other goes down at the same rate, and to be able to solve problems with compound measures. So compound measures, measures where there is more than one unit involved. So again, before we start, we need to check our prior knowledge. Now this bit today is quite important. We need to be able to do this before you can complete this lesson. So you should be able to convert between metric units of length. So we should know that 1 kilometre is 1,000 metres, 1 metre is 100 centimetres, and 1 centimetre equals 10 millimetres. So we need to be able to convert backwards and forwards between those units of length. You also need to be able to convert between measures of time. So we should know that 1 hour is 60 minutes, quarter of an hour is 0.25 hours, quarter of an hour is 0.25 hours, or 15 minutes, and that half an hour is 0.5 hours or 30 minutes. You should also know that if you want to convert any other amount of minutes into hours, you do the number of minutes divided by 60. So it's what fraction of 60, because there are 60 minutes in an hour, and that will give us the decimal value in hours. Please make sure you're happy with those before you move on. We're going to be using those a lot throughout this lesson. So you might want to just pause, make a note of them if you're not sure, or go back and have a look at those before you complete this lesson. Okay. So to start then, just a quick knowledge check. So there are 4 questions there about converting between measures of metric length. So can you pause the video, have a go at those, make sure you're happy with those. Feel free to use a calculator if you need to. Okay, let's have a look at the solutions. So the first one, so Snowdon, the highest mountain in Wales, 1,085 metres high, and we want it in centimetres. So to change from metres to centimetres, we know there are 100 centimetres in a metre, and if I want to go from metres to centimetres, I times by 100. So 1,085 metres is 108,500 centimetres. So we've simply times by 100. Usain Bolt is apparently quite good at running. He runs the 100 metres. How many millimetres is this? Now we can't just jump from metres to millimetres. We usually go metres, centimetres, millimetres. So if we start with 100 metres and change it into centimetres, so remember metres to centimetres, we're going to times by 100. So 100 times 100 is 10,000 centimetres. And centimetres to millimetres, there are 10 millimetres for every centimetre. So we're going to times it by 10, which gives us 100,000 millimetres. Robert Wadlow was the tallest person who ever lived, so he stands at 2,720 millimetres tall, and we now want that in metres. So again, we've got to go the other way, so we've got to go to centimetres first and then to metres. So 10 millimetres per centimetre, so if I want to change to centimetres, I need to divide by 10 first of all. That gives me 272 centimetres, and there are 100 centimetres in a metre, so we need to divide by 100, so 2.72 metres. Okay, and finally then, the Great North Run is a run up in Newcastle. It's 21 kilometres long in total. How many metres will people be running? So kilometre, remember, means 1,000, so there's 1,000 kilometres. That's right, 1,000 metres in a kilometre. So to change from kilometres to metres, we need to times by 1,000. So 21 times 1,000 is 21,000 metres. So make sure you're happy with those conversions, making sure you know whether you need to multiply or whether you need to divide to change between those units. Okay, so compound measures then. So our compound measures are where we're using 2 different units together. So in our example then, petrol is leaking from a tank at a rate of 5 litres per hour. So that's our compound unit. We've got litres and we've got hours in that same unit. So let's start off by writing that down. So we said 5 litres per 1 hour. So when it says per hour, it means for 1 hour. So 5 litres equals our 1 hour. So we're going to use a method here of comparing values. There are different ways of being able to solve these, and you might find different methods online, but I'm going to use the method of comparing. Okay, so it's very similar to what we would do when we're doing ratios. So if we said 5 litres, it takes us 1 hour, and we want to know how much in 30 minutes. So under the hour side, I'm going to put 30 minutes. Now 30 minutes is 0.5 hours, half an hour. So we've got to get from 1 hour to half an hour. So how do we get from 1 down to a half? Well, we half it, we divide it by 2. So to get from 1 to 0.5, we're going to divide it by 2. Whatever we do to one side, we need to do to the other side. So we're going to divide the other side by 2. So 5 divided by 2 is 2.5 litres. So it says, how much petrol leaks in 30 minutes? Well, our answer is 2.5 litres. Now, don't forget to write your answers separately. So this bit here is our working out our method, and then we need to definitely state our answer nice and clearly. So don't assume that because your answer is inside this diagram that people will know which answer is your answer, because there are 4 different values there. So it needs to be nice and clear which is your answer. Okay, now we're going to have a look then at how much leaks in 4 hours. So this time then, again, under the hours side, I've put 4 hours. To get from 1 to 4, now 1 is bigger than 4. Sorry, no it's not. 4 is bigger than 1. So to get from 1 to 4, we're going to multiply. So we need to multiply by 4. Whatever we do to one side, we do to the other. So I'm going to do 5 times 4 is 20 litres. Finally then, we're going to have a look at 6 minutes. Now, we're using hours, so our first step is to change 6 minutes into hours. So remember we said at the start, to change minutes into hours, it's the number of minutes divided by 60. So our 6 divided by 60, that's how many hours, and if we put that in our calculator, that's 0.1 hours. Now we've got to get from 1 to 0.1. 0.1 is smaller, so we're going to divide, and we have to work out what to divide by. If you're not sure what to divide by, if I do 1 divided by 0.1, that will tell me the divisor. So our divisor this time, if I do 1 divided by 0.1 is 10, so we're going to divide by 10. If we divide by 10 one side, we divide by 10 the other, which gives us 0.5 litres. So for 6 minutes we have 0.5 litres. Okay, so by using this method of comparison, whatever we do to one side, we do to the other. If we're going to move from a big number to a smaller one, then we need to divide. If we're going from a small number to a bigger one, we're going to multiply. So we need to always work out what we're dividing or multiplying by. Finally then, the petrol tank holds 100 litres. How long does it take for the tank to be empty? So again, we'll start with our original value, which is 5 litres is equal to 1 hour. But this time we're told how many litres we've got. So under the litres side, we're going to put the 100 litres. Now we've got to get from 5 to 100. 100 is bigger than 5, so we're going to have to multiply. Again, if you're not sure, we need to find out how many 5s fit into 100. So if we do 100 divided by 5, that gives us an answer of 20. So 5 times 20 is 100. So we do the same to the other side. So we're going to times it by 20. 1 times 20 is 20 hours. So it will take us 20 hours for the tank to be empty. Make sure you're happy with those. Pause the video if you need to make any notes before you move on. Okay, so our next set of examples then. We've got a car travels 150 miles using 30 litres of petrol. What is the average rate of petrol in litres per mile? So litres per mile means how many litres are we going to use for 1 mile? So when it says per something, that's per one of those items. So we'll start off with our statement then. We know 150 miles uses 30 litres. Now, as we said, litres per mile means litres for 1 mile. So underneath the miles, we're going to put 1 mile. And I've got to get from 150 down to 1. So to get from 150 to 1, we must need to divide by 150. So we divide both sides by 150 and that gives us 0.2 litres. So our units then 0.2 litres per mile. So again, that told us we needed 0.2 litres, but our unit is in our compound unit of litres per mile, so 0.2 litres per mile. So that's why it's so important we write out our answers separately. Finally then, estimate the amount of petrol the car has used when it's travelled 200 miles. So we already have worked out here that 1 mile is 0.2 litres, so we can use that bit of information. So now we know we've got 200 miles, so we're going to put that under the miles side. To get from 1 to 200, I need to multiply by 200. So we do the same the other side, and that gives us 40 litres. So the amount of petrol that we've used is 40 litres. Again, pause the video if you need to, copy down the examples if that helps you. Okay, so now it's your turn. So pause the video, have a go at working these out using that same method. You will need to use a calculator for these. Okay, let's have a look at the solutions then. So we've started off with 250 kilometres equals 20 litres of petrol, so we've written our statement at the top. We want to know the average rate of petrol usage in kilometres per litre. So that's kilometres for 1 litre. So we put 1 litre underneath the 20. To get from 20 down to 1, we've divided by 20. So we've divided both sides by 20. And we get 12.5 kilometres per litre. Next then we're asked to estimate when we've travelled 50 kilometres. So again, started off with my 250 kilometres is 20 litres. Now I'm going to get from 250 to 50. So that's how many 50s am I fitting into 250? Well, there are 5 that fit in. Again, if you're not sure, you do 250 divided by 50. It will tell you your divisor. So we're going to divide them by 5. So we divide the other side by 5. 20 divided by 5 is 4. So our answer is we'll use 4 litres. For the next one then, we've got a rate of 12 degrees per second. So 12 degrees equals 1 second. And we want to know how far after 20 seconds. To get from 1 to 20, we've multiplied by 20. So we do the same the other side. 12 times 20 is 240 degrees. Now we want to know how long it will take for the windmill to make a full turn. Now we need to know a full turn, remember, is 360 degrees. So under our degrees side this time, we've got 360. So we need to see how many 12s do I need to get to 360. So to work that out, we do 360 divided by 12. That tells me what I'm going to multiply 12 by, and it's 20. So we do the same the other side. 1 times 20 is 20. So it will take us 20 seconds. Finally then, we've got a car that travels 16 kilometres per litre. So remember, 16 kilometres for 1 litre of petrol. And we want to know how many litres it uses per kilometre. So now we want for 1 kilometre. So under the 16, we're going to put 1 kilometre. To get from 16 to 1, we divide by 16. 1 divided by 16 is 0.0625. So it's 0.065 litres per kilometre. And finally, how far could we travel on 48 litres of fuel? So again, we'll start with our 16 kilometres plus 1 litre. This time we're going to put the 48 under the litre side. To get from 1 to 48, we're going to multiply by 48. 16 times 48 is 768. So we could travel 768 kilometres. Pause the video if you need to. Make sure you've checked through all of those. Okay, let's have a look at a real life situation then where we may need to be able to use compound units. So George works a basic 35-hour week and is paid time and a half for each hour he works on Saturday and double time for each hour he works on Sunday. His basic hourly rate of pay is £7.50. How much is George paid when he works a 35-hour week plus 4 hours on Saturday and 3 hours on Sunday. So whenever we're doing these longer problem solving type questions, we need to break them down into small parts and we need to clearly label our work. So let's start off with his normal weekly pay then. So his weekly pay, he's working 35 hours during the week and he gets £7.50 per hour. So that's £7.50 for every hour that he works. So on weekdays we have our £7.50 times 35, so it's times because it's £7.50 for every hour, and that gives us £262.50. Now it says on Saturday he gets paid time and a half. So time and a half is how much he'd normally get paid plus half as much again. So I need to first of all work out how much he's going to be paid per hour on a Saturday. So £7.50 times 1.5, so that's time and a half, means he gets now £11.25 for each hour that he works on Saturday, and he worked 4 hours, so he got £45 for Saturday. Sunday, it says he works double time, so that means he gets twice as much as normal. So 2 lots of £7.50, so that's £15 for every hour that he works on Sunday. He worked 3 hours on Sunday, so 15 times 3, he gets £45 for Sunday. And we want to know how much he got paid for the whole week, so we finally need to add those together. So his total pay, £352.50. Okay, again, make sure you're happy with how we've worked that out. So remember, time and a half means 1.5 times how much you normally get. Double time is 2 times how much you would normally get. So we work that out first to find our hourly rate, and once we know our hourly rate we can multiply that by how many hours we're working to find out how much money we would get. Okay, so your turn. So a very similar question for you there. Read through it carefully, break it down into weekdays, Saturdays, Sundays and total. Set out the work nice and clearly so it's easy to follow. Pause the video and have a go in your maths book. Okay, so let's have a look then at how we do this one. So on weekdays, she got £10.20 and she did 30 hours, so that's £306. Saturdays, this time she got time and a quarter. So time and a quarter is 1.25, 1 1/4. So that's £12.75 per hour for 3 hours, £38.25. On Sunday, she got time and a half, so that's 1.5 times £10.20. So she got £15.30 per hour, and she did 4 hours, giving her £61.20. And her total then, if we add all those together, is £405.45. Okay. Thank you very much then for working through this lesson with me today. The second part of this lesson, again on compound measures, but this time density, is there if you click on the link below.